let's make sure that we really have dynamic routing protocol config cooked in our topology. So what I want to do is this. Let's inspect our routing protocols right now. I'll do a show IP protocols. Okay. So EIGRP is not running in our topology. That's the protocol we're going to use. I'm going to go to PC1 right now, and I just want to make sure that I can ping still between PC1 and PC4, and I just ran a ping. That's going the right place. It's working. We're all set. So inside of my switch block, I do have connectivity, but I can't get anywhere beyond that. For instance, and let's validate this, because a successful config at the end will be me pinging 192.0.2.1. Destination host unreachable. And it's really because DSW1 doesn't have any clue on how to get the traffic there. We want to build dynamic routing, and R1, R2, R3, R4 are configured. Let me show you what that looks like. So I'll do a show run section EIGRP, just so you see the EIGRP setup. It's really just a super straightforward config. If it'll ever show, there we go. Nothing fancy. But that'll enable EIGRP on all the interfaces in the 10 network, and that's what I want. And I've got 10.1.13 between those two devices, and 10.1.23 between these. We're just going to set it up between DSW1, by the way. DSW1 and R1. So we're going to go to DSW1 and just validate that we don't have any routes. Router EIGRP 100. Network. Now this will enable EIGRP on all interfaces in 10 network. Let's undo that. I want to do it this way. Network, I want to be careful. You may be told to configure network statements in such a way that you're only enabling them for the VLAN interfaces that participate in routing. So you may be given instructions to craft a really small wildcard mask, one that is the inverse of the subnet mask. And that would be the inverse of a /26 mask. Then I want to set up, so that's the IP address that I want to configure. I want to match that, and that should be the command that sets up neighborship between us and R1. So let's look at my routing now. Show IP route. EIGRP. That's a lot of routing. Great. So I'm probably able to get around my network. Now, let's see if R3 can ping that client. This will say that I have internal reachability. Good. Get a few drop frames sometimes because of I do have some funkiness going from some virtualized clients. So that don't get caught up in that. My connectivity is sound. It's just some virtualized interfaces to get to these PCs. So I'm happy with that. But can the PC reach the outside world? Still no. And it's still a routing issue, believe it or not. What I want to do is I want to advertise a dynamic default route. So I don't have that yet. And I saved this because, hey, this is a real world thing. Do a show IP route static. I do have a default route. So what I'm going to do is this. I'm going to redistribute the dynamic default route. And these are the inputs to the K values for the seed metrics of the EIGRP external routes that we just created. Now, can the PC reach it? Come on. Okay, so we're getting a little bit of flaky connectivity between these. Again, that is just a product of my odd topological challenges with media between the virtual world and the physical. So this is working great. This is working great. The topology is set up so that I have reachability to the very distant server that I'm pretending to be the internet. Getting the full routed connectivity inside of your autonomous system, your campus, is really rewarding. And it takes a lot of different ingredients to make it work, but one of those big ingredients is dynamic routing config.